So for these last few, or actually it's not the last few, but it's the same problem type, but now we're dealing with E, which is why I thought it was a good time to stop the video and go for a new one. So I have 0.86. All right, so I have E, which is a number, raised to the negative 0.68t, and that's going to equal 0.86. So what does this mean? Up until now, we have not really cared which log we've used. So I know I'm going to have to go to log world because I got to get that exponent down. Now, since I know base E corresponds to natural logs, it will benefit me greatly to use natural logs in this problem, and you'll see why in just a second. But just as an FYI, if you ever have a base of 10, use common logs. If you ever have a base of E, use natural logs. If you have anything else, it doesn't matter what you use. Okay, so I know I need to get this exponent down. So this is an exponential equation. It's problem type 3. And I need to be able to use logs so I can drop that exponent out front. So again, I'm going to go ahead and use the natural log. And I'm going to take the natural log of both sides. What does that allow me to do? That means I can now grab my exponent and write it out front as a coefficient. And then I've got 0.86. Okay. Now here's the cool part, which you learned several videos ago. What's your base here? If it's not written, it's either a 10 or an E. So there's a little E sitting there that I'm usually too lazy to write. What is your answer if your base and your argument match? That immediately simplifies to 1 because E to the first power is E. So this is just equal to 1, and 1 times anything doesn't change what it is. It's just itself. So that's gone. I don't even have to use it anymore because the natural log of E equals 1, and 1 times t times negative 0.68 is going to be negative 0.68t. And now it's more familiar now. Remember, this is just a number. So I'm trying to get t by itself, so I'm going to divide both sides by negative 0.68. So it's going to disappear from the left, and it'll appear in the denominator on the right. So when I enter this in my calculator, again, be very careful with your arguments. So I'll have the natural log of 0.86, close that argument, divided by negative 0.68. And when I do that, I get 0.2218. Okay, 0.2218. 0.2218. So it's just slightly different. It benefits you to use the natural log. Let's do E to the 4c minus 5. And that's going to equal B. And one of the things that I noticed, remember, E is not a variable. E is a number. So I see that I've got two variables, B's and C's, and it says to solve for C. So I knew something weird was going on, okay? Well, I'm in exponential world, and I need to be able to grab that exponent and drop it out front so I can reach the C and manipulate it. And I notice that I'm also dealing with E's. So that means I'm going to use natural logs because it's going to help me in the long run. So I take the natural log of both sides, and that allows me to drop my 4c minus 5 out front in parentheses as a coefficient. So remember that 4c minus 5 belongs to the natural log of E. Okay, so drop it out front in parentheses. And that's going to equal the natural log of B. Well, now we're excited again because what is the natural log of E the same thing as? Your base, which is you're too lazy to write, your base and your argument match, so that equals 1. And 1 times 4c minus 5 is 4c minus 5. So I'm just going to rewrite it so it's a little bit friendlier. And I've got the natural log of B, and now I'm just going to get C by itself. I don't care what's over here. So I need to add 5. So I'll get the natural log of B plus 5, and this is where when I'm writing, I would be very, very, very clear. And now I'm going to use those parentheses around my argument. so that you know to add it to the natural log of b, not just the b. And c is almost by itself, so I'm going to divide both sides by 4, and now I know what c is. Okay, we have log base 5 of x plus 10 plus log base 5 of x minus 10, and that needs to equal 3. So what is your bigger picture? Your bigger picture is I've got logs on one side and numbers on the other. So it will benefit me to put these together. So I have I want a single log. Well, if it's joined by addition on the outside, how do I join it on the inside? It's going to be multiplication on the inside. So I've got the argument, and I'm going to multiply x plus 10 and x minus 10. So x plus 10 times x minus 10, and that's going to equal 3. So now what do? I am going to change this to exponential because it looks like the problem type, the first problem type I gave you. And so if I got a single log equal to something else, change it to exponential. So 5 raised to the third power equals, and I'm going to go ahead and FOIL this out. So x times x and x times negative 10 is going to be x squared minus 10x. Then I get plus 10x. So my negative 10x and my positive 10x cancels, and then I have a minus 100. Okay, what do I do now? I'm trying to get x by itself. Well, do I know what 5 to the third is? I do, because 5 times 5 times 5 is 125. Okay, so now what do? I need to subtract 125 from both sides. So I get x squared minus 225. Now you can approach this two different ways. And what did we forget, everybody? We forgot we started in log world, so you better check your answer. I haven't needed to do that for a bit. This is the difference of two squares, so you can factor that if you want to. Or I can get x by itself and add 225 back over. So now I've got an x squared equals a positive 225 because I added it. Well, now what do? I don't care what x squared is, I care what x is. So how do you kill a square? You square root it. So I get x equals, and remember any time during the process of solving a problem that you've got to take a square root. You need to take a positive root and a negative root. So the square root of 225 is 15. So I actually end up with positive 15, and I end up with negative 15. So I have two answers. I need to check them. So if I shove in a positive 15, 15 plus 10 is positive and not 0. 15 minus 10 is positive and not 0. So positive 15 works. What about negative 15? Negative 15 plus 10 just sent you to negative land. So I don't even need to try this one. Okay, it failed one. It only needs to fail one. So negative 15 does not work. Remember that negative 15 is extraneous. So you have a single answer, and it is positive 15. A single answer, and it is positive 15. All right, we got a couple more to go. I have 3 to the x squared minus 2, and that equals 21. All right, so first of all, I'm in exponential world. Can I make my bases match? Can I rewrite 21 as a power of 3? No, because 3 to the first is 3, 3 to the second is 9, and 3 to the third is 21 or 27. I just skipped over the 21. So I know I'm going to have to use logarithms to get this thing down. So my next question is, do I confidently know base 3 or base 21? No, I really only am familiar with base E and base 10. So I don't care which log you use as long as you use one of them. So I'm going to take the log of both sides. That allows me to drop my exponent out front as a coefficient. So I get x squared minus 2 times the natural log of 3, and that's going to equal the natural log of 21. So before you dive in and start doing stuff, what are you trying to get by itself? I'm trying to get the x by itself. So in the past, we've distributed this natural log of 3. I don't have to do that this time because there's not multiple things. I don't have x's and numbers on the other side. Okay, so I might as well just divide both sides by the natural log of 3. So I've got an x squared minus 2 equals the natural log of 21 over the natural log of 3. Do not change that to the natural log of 7. Okay, this is change of base. So you're changing it from a base of 3 to a base of e. Well, I'm still just trying to get x by itself. So this is a number divided by a number. Get x by itself, so I'm going to add 2. Okay, I am going to add 2 to both sides. And now I've got x squared equals this entire mess. So I need to know what x is. Anytime you need to take a square root during the process of solving a problem, make sure you take a positive root and a negative root. So I have x equals plus or minus this huge mess right here. So I'm going to go to 4 decimal places. So in your calculator, I'm going to take the square root of this entire thing. So the square root of what? The square root of this divided by this. So it's going to be the natural log of 21 divided by the natural log of 3. Make sure you close both of those arguments. Okay? And then what do I do once I find that answer? I add 2 to it. So I get 21843. So plus or minus 21843. Since I did not start in log world, I don't care if I generate positives or negatives. So you're going to have 2 answers for this one. And they'll both work. All right, we have 4 times e to the x plus 2 equals 16. So what is my mission? First of all, I notice I'm working with e's, so I'm already drawn to the fact I'm going to use natural logs. And I'm trying to get this x by itself. Well, now there's some clutter in the way. I need to get rid of that 4. Before I take any natural logs, everything I've done up until now, I've already had my exponent and its base by itself. Well, now I don't. So let's get it by itself first. So I'm going to divide both sides by 4. And that's going to give me an e to the x plus 2 equals 4. Because 4 divided by 4 is 1. That's where it went away. 16 divided by 4 is 4. So now go one more step. I need to subtract 2. So e to the x needs to equal 2. And now you're in a familiar territory. So I have an exponential. I need to get x down out front. So how do I do that? I'm going to take the natural log of both sides because I'm working with e's. So I've got the natural log of e to the x equals the natural log of 2. Why did I do that? Because I'm in log world and I can drop my x out front as a coefficient. And then the last thing is, what do I notice? My base, which I'm too lazy to write, is e. My argument is e. My base and my argument match. That's the same thing as a 1. So all I have to do is poke the natural log of 2 into my calculator, and I get 0.6931. So x is 0.6931. All right, we're running tight, but we're going to do one more. So the amount of a certain radioactive material in grams in a storage facility at time t is given by, so we are told a formula. So I've got C of t equals 81 e to the negative 0.12 t. So t is in years. So how much of the radioactive material was present initially? Well, that would mean that time is 0, because time hasn't passed yet. Okay, time has not passed yet. So if time is 0, that means if I evaluate it 0, I get e to the negative 0.12 times 0. Well, that means I have 81, e to the 0 times anything is 0. Any number to the 0 power is 1. So 81 times 1 is 81. Okay. So at time 0, I had 81 grams present in the storage facility. So part 2 says, what is the half-life of the radioactive material? So I need to figure out, so first of all, if I started with 81 grams, then what is half of that amount? Half of that amount is 40.5. Okay, so I want 40.5. So I'm trying to have 40.5 grams because that is half of what I started with. And now I have e to the negative 0.12 t. So I'm going to divide. Remember, I can't go into log world. I can't start getting that exponent down till just the e is there. Whatever the exponent is attached to, that needs to be by itself. So that 81 is in my way. So divide both sides by 81. And miraculously, you're going to get 0.5 or 1/2. And that equals negative 0.12 t. Okay, so this is the half-life. You're finding what makes it go to half. Now this is by itself. So what are we going to use? Common log or natural log? I like e. I'm going to use the natural log. So I've got the natural log of 0.5 equals the natural log of e to the negative 0.12 t. Why did I do that? So I could drop this out front as a coefficient. So I've got the natural log of 0.5 equals negative 12 t times the natural log of e. And what have I learned so far? The natural log of e equals 1. And 1 times anything is itself, so now I just need to get t by itself. Divide both sides by negative 12. And that is going to give me, what is that going to give me? The natural log of 0.5 is, and then divided by negative 12, it gives me 577,622. So 577,622 equals t. So almost 6 years. It took almost 6 years for it to decay halfway. Okay, and that is section 4 out of chapter 4, which means you are now officially ready for your chapter 4 test. So I will see you in chapter 5.